Yeah, welcome back to my class. Today we want to look at logical operators. We've looked at arithmetic operator, we have looked at relational operators. Now we want to look at logical operators. Now, these are the strategists, right, in the program realm. So what do? They ensure that the truth of the logical realm is obeyed and implemented. So how do they work and what are these type of logical operators? We are looking at the logical and, right? Logical and, this is like this. And then we have the logical or, this one, let's put it this way. Then the logical or, in C, it is represented with this symbol. Then we have the logical not, right? Which is represented with this symbol. So what does this do? This ensures that the two operands are true before the outcome will be true. Why this one, the logical or, if any of the operand is true, the outcome will be true. Let me give you a circuit demonstration of this logical and. Let's say you have something like this, right? Then this is a bulb. Now, at this level, I want you to see a physical demonstration because it's like AND gate or OR gate. Now, you bring this here. So for the logical AND, you have this switch and then this switch, then this one here. So for this bulb to come on, right? Then this switch need to be closed and this switch need to be closed. Both has to be closed before this bulb can come on. If this one is closed and this one is open, this will be off. If this one is closed and this one is open, this will be off. So it has to be the two that will be on before this can come on. This is for logical and, right? Now, for this logical or, you have something like this. So you have something like this. This is for or. If I close this switch and this one is open, this bulb will come on. If this one is open and I close this one, this bulb will come on. So we have truth tables for them. So I'm just going to show you the truth table for this logical and then this logical or and the not. So for this one, we have, let's say we have variable A and variable B, and then this is the output, right? So we have this. So here we have, if this is true, this is true, this is false, and this is false, right? If this is true and this is true, then this is false, this is true, and this is false. So this is the truth table, right? So if this is true and this is true, then this output will be true. If this is true and this is false, then, so this one, I will say A, B, right? So if this is true and this is true, this one will be true. If this is true and this is false, this will be false. If this is false and this is true, this will be false. If this is false and this is false, this one will be false, right? This is the truth table for logical and. Now, for this logical or, we have something like this: A, B, then you have A or B. Then you do this. Same thing. So this is true. This is true. This is true. This is false. This is false, this is true, then this is false, this is false, right? So if this is true and this is true, this one will be true. This is true, this is false, this will be true. This is false, this is true, this will be true. This is false, this is false, then this will be false. So you can see it's the reverse of this. False, true, false, false, false. Why this one is true, 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 false. That is the table, the true table for logical OR, and then the true table for logical AND. Whereas this not, if this is true, then not will convert it to false. If this is false, not will convert it to what? To true. So that is basically what this logical and logical OR and logical NOT, this is what it does. So let's write a simple program that will operate this. So I'll just say hash include stdio.h, and then we'll say int main, and then we'll come here. So we'll declare two variables, int a, we assign 10 to it, then b, we assign 5 to it, and then we'll close this. Then we'll come here and we'll say print f, and then we'll put this in parentheses. So here we'll say a and b. Then we'll put our format specifier d, and then I'll put my escape sequence. Then I'll close this, comma. So then I'll do this here. B. Then I'll close this. Here I will say print F. I will say A or B. Then I will do this, my format specifier D. Then I will put my escape sequence. Then I will say A or B. Then I will do this. Here I will say print F. Then for the logical NOT, I'm just going to say this, then A greater than B. Then I'll put this, and I'll do this, and then I'll close this, and I'll do this. So I'll say this, A greater than B. Then I'll close this. Then I'll say return 0. I'll close this, and then I'll close my curly bracket. So if I run this script, what am I going to get? So this will be printed out on the screen. A and B will be printed out as a string literal on the screen. Then it will check. So this is the logical operator. So it's going to compare this and then take a decision. A and B, anything that is non-zero in C is considered to be 1, which is what? True. So this is true and this is true. So this one will return 1. A or B, this is true or this is true. This one will return 1. Now, in this place, A is greater than B. A is greater than B. This is true. This logical NOT will return false. So this will return 0. Now, if I change this place, if I remove this and I change this to 0, A and B, this is false. Why this is true? This one will return 0, which is false. That is, it will return false. It will return 0. Then A or B, this is 1, this is 0. So this one will return 1, based on what I showed you on that switch. Why this one? A is greater than B. A is 0, B is 5. A is not greater than B, that is false. But this will change it to true. So this one will return 1. That will be my output. So that is the operation of what? The logical operators. So let's go to code blocks and let me demonstrate this for you to see. And if you have come with me this far, don't forget to subscribe to my channel. Please give me a thumbs up. So let's go to code block. All right, so these are logical operator. We declare two variables, which is A and B, and we assign 10 to A and we assign 5 to B. So this is the program. This one is going to print out A and B, which is a string literal because of this double quote. So this is the expression, A and B. Because of in C, anything that is non-zero is 1. So, and that is true. So A is true, B is true. So this one will return true, which is what? 1. A or B, this one will return 1. While A is greater than B is true, but the not will change it to false. So that will be 1, 1, 0. So let's run this one first and see what the output will be. So you see, the first one will return 1, the second one will return 1, and then the last one will return 0. So I'm just going to change the value of A to 0, and then we will execute and run again. Now, see what it's giving you. A and B, because 1 is false and this one is true, is going to give us false, and that is 0. So A or B, that one, you just need 1 to be true, and that will give us 1. A is greater than B, that is false. While the not will change that false to true. That's why you are getting 1 as the output. So that is what the logical operator is doing to you. So that is what I want to show you in this class. So till we see in the next class. Bye-bye.